Hey everyone, so welcome to homework 3.3. Today we looked at our exponential functions and just got a little bit more practice with those. So this first question is asking which expression is equal to 4 to the 0th power times 4 to the 2nd power. Remember that anything to the 0th power is 1, so this is 1 times 4 to the 2nd power, which is 4 squared, so that's 16. So select all expressions that are equivalent to 3 to the 8th power. So 1, we can go ahead and we can say we're multiplying 3 times itself 8 times, all right? That is not going to be A, right, because this is 8 to the 3rd power. That's different. This one, because it's division, we would subtract our exponents. So this would be 3 to the 8th power. This is just 3 times 8, which is 24, so that's incorrect. This, because our exponent is outside of the parentheses and we are raising a power to the power, this we would multiply, so it would be 3 to the 8th power, so this is true. Here, similarly, we would make this 3 to the 4th power times 3 to the 4th power, which is then going to be 3 to the 8th power, so this does work. And then this is 1 over 3 to the negative 8th power, which is tricky because this would be 1 over 1 to the 3 to the 8th power. Well, 1 divided by 1 over 3 to the 8th is the same as 1 times 3 to the 8th over 1. So this is also equivalent. All right, let's take a look at the next one. A bee population is measured each week and the results are plotted on the graph. What is the bee population when it is first measured? So we can tell this by the starting value on our y-intercept, and so this is going to be 500. We're going up by 500 here. It says, is the bee population growing by the same factor each week? Explain how you know. So after the first week, it is 1,000, and so 1,000 divided by 500 gives us 2. And then the next week it's 2,000, 2,000 divided by 1,000 gives us 2. So we can see that, yes, it is doubling. So by a factor of 2. It said, what is an equation that models the bee population? B, W weeks after it is first measured. So we'll say B, or we can say B of W if you want it to be a function, equals 500 times, that's the initial amount, times 2, which is our factor, to the power of the weeks. Number 4, a bond is initially bought for $250. If you don't know what a bond is a way to invest your money, and you buy it for a certain amount, and it increases in value over time. And so this is, in this case, it doubles in value every decade, every 10 years. That's what a decade is, okay? It says complete the table. So if it starts at 250 and then it doubles, it'll be 500, then 1,000, then 2,000, then 4,000, right? Times 2 each time. It says how many decades, oh, I'm sorry, actually this last one is not times, it is D. So this would be 250 times 2 to the power of D. It says how many decades does it take before the bond is worth more than 10,000? So if we keep along this trend, right, and we say 4, 5, 6, 7, 8, we're going to be at 4,000, 8,000, 16,000, 32,000, right? And so at this point here, we are now over 10,000. So it'll take between 5 and 6 decades. Right, because probably sometime after this 5th decade, but before this 6th decade, it'll hit that 10,000. If we are only counting by full decades, then it would take 6 decades to get over 10,000. It says write an equation relating V, the value of the bond, to D, the number of decades. So V of D equals 250 times 2 to the power of D. Right, a sea turtle population P is modeled by this equation, where Y is the number of years since the population was first measured. How many turtles are in the population when it is first measured? So that is 400. It is the starting, not about, the starting amount. And it says, is the population increasing or decreasing? How can you tell? So it is increasing because we multiply by a number greater than 1. So 5/4 is, right, 1.25. It is greater than 1. It's written as a fraction, but that fraction is still greater than 1. It says, when will the turtle population reach 700? Explain how you know. Well, let's go ahead and make our table, right? So if we have our initial population of 400, oops, I did that backwards. It's here. The 0, it is 400. After 1 year, it would be 400 times 1.25. So 400 times 1.25 gives us 500. After the second year now, we're plugging in 2 for here. So that is 1.25 squared, which is 1.5625, times 400 gives us 625. All right. Then going from our next one, if we're doing 5/4 or 1.25 to the third power, and then multiplying by our original amount of 400, we get 781.25. So the turtle population will reach it between years 2 and 3, but definitely after year 3. All right. So again, you can make that table, plug in your years for y, and then you calculate first that exponent and then multiply by your initial value. All right, number 6, Bank A starts with 5,000 and grows 1,000 each week. Bank account B starts with 1 and doubles each week. So after 1 week, it says which one has more. And then obviously still after 1 week, we have the one with 5,000. So this is Bank A. And then after 2 weeks, still Bank A still has more. And we can see that in this graph here. Because in, Bank B, we would still only have $2 than $4. It's still a much less amount than in Bank A. But it's given a choice, which of the two accounts would you choose? Explain your reasoning. So here you want to tell me when you would want which account, right? So if I am doing up until 14 weeks, right, at week 15, my exponential account suddenly increases a lot. So before week 15, I would choose A, but after 15 weeks, I would choose B, right? Because at this point, my exponential function is now worth an incredible amount more than my Bank A, where I'm going up in a linear function. So this would depend on when I am using that bank account, or for how long, rather. Number 7 says match each equation in the list to an equation in the second list that has the same solution. So this is a review for you to find your equivalent expressions and equivalent equations. And so let's look and see what we have here. So in this one, we have all positive values, and we have x and y on the same side. So looking at this, if I were to multiply this whole thing by 5, I would get 5y equals 2x plus 10. So in this case, I would have one with a negative and one with a positive if I move it to the same side. So this would be negative 2x plus 5y equals 10. So A matches with equation 3 very nicely. If I'm looking at B, then here again, I want to get to a new equation. This would be negative 2/5. So negative 2/5, oops, not 2/5, negative 2.5 is the same as negative 5/2, right? And so in this case, I would multiply the whole thing by 2. And I would get 2x equals negative 10 minus 5y. All right, now here, in order to rearrange this, I would add 5y to both sides. And so then I would have 2x plus 5y equals negative 10. So that's not the same as any of these exactly, but if I were to then multiply this, let me just show you over here. So if we have 2x equals negative 10 minus 5y, I can also rearrange this by subtracting 2x on both sides. And then I would have 0 equals negative 10 minus 2x minus 5y. And then I can add 10 on both sides to get rid of this here. So now I have 10 equals negative 2x minus 5y. So this is actually equivalent to this one here. You could also see that by multiplying by a negative 2 instead of a positive 2. We'll get you that same answer. All right, here, again, I would probably multiply by 5 to get rid of that denominator there. And I would have 5y equals 10 minus 2x. All right, so here we can again see if I want to put my x's on both sides, I would add 2x to both sides. And so this would be 5y plus, that's 2x. So that matches nicely with this one here. Let's take a look at the next one. Here again, if I wanted to move this to be with the other side, I would add 5y. So this one also matches with equation 1. And this one here, if I subtract 2x, I would have negative 2x, negative 5y equals 10. This is equation 2. And then our last one, let's multiply this whole thing by 2. We will get 2x equals 10 minus 5y. So this is very similar. We would add 5y to both sides, so they'd both be positive. So this one actually also matches with equation 1. All right. Another review question, function f is defined so that its output, f of t, is the number of followers on a social media account t days after setup of the account. Explain the meaning of f of 30 equals 8,950. So this is after 30 days, there are 8,950 followers. If you're listening, write the word Instagram here. That will tell me that you are actually listening to this. So f of 0 equals 0 means at the start, there are no followers. So when they initially start, the input is 0 and the output is 0. It says write a statement about function f that represents the fact that there were 28,800 followers after 110 days. So f of 110, let me just make sure this is days, yep, equals 28,800. Remember, this is just our function notation. This tells us input, this tells us output. And then it says explain the meaning of this equation, f of t equals 100,000. So this is at some number of days, represented by t, there are 100,000 followers. All right, that is it for your homework. Your code word today, I gave you a space to put your code word at the very top here. So put your code word here today because that will help me to know that you did it and give you extra credit. Your code word today will be TikTok, and please make sure that you listen carefully. All right, happy homeworking and see you tomorrow.